My name is Don Fisher. I'm the interim principal here, and welcome to all of you, but particularly folks who haven't been here before. If it's your first visit, we hope it won't be your last. First, let me recognize that we're on the unceded and traditional and occupied territories of the Musqueam people. This land clearly is very much Musqueam territory, if you know the geography around here. And we try to build and make a strong relationship with the Musqueam Nation over the years, and that continues. The program tonight, second in our series we call the Appetizer series. Give you some sense of what this is all about. Each year we invite first and second year full-time faculty to apply to be part of a leading scholar cohort. So this year there are 20 plus, I think 25, but certainly 20 plus leading scholars representing a whole range of disciplines across campus. And the idea is to bring them together to talk to each other, talk about their work, and of course look for all of those connections and make all those connections that inevitably exist between different knowledge units, disciplines and fields. The theme of the college, again for visitors, is interdisciplinarity. So this has become very much a flagship program where we are promoting and I would say practicing interdisciplinarity with these sessions. Tonight then we just have two folks. Two of our cohort couldn't come. The transit, they were relying on transit, so they're not here with us. That doesn't matter. We're going to have a really great conversation. I've asked Torsten and Jaya to speak for 15 minutes each about their work, and then invite them to talk to each other, talk about the questions they have for each other, and if you've read the abstracts, you can see there's all sorts of ways in which that's likely to occur. And then we'll open it up for a longer conversation. We normally go through, sometimes at least we don't have to, but we normally go through to 6:30. The latest we'll go tonight is 6:15, but if we just run out of conversation here, we'll stop, go over to wine and cheese and continue it there. So thank you for coming, and let me welcome both of you. Torsten, you going first?
Yes.
Good. Great.
Is this mic on now? Yeah. Okay, good. Can you hear through the mic if I stand back here? No? Okay. Let's move it a bit closer. Okay. Okay, great. Thank you. So my name's Torsten. I'm in the Vancouver School of Economics as an assistant professor. And this is really an overview of work that I started in my thesis at the University of Toronto and that I'm sort of continuing now in the early years of my professorship. And the title is going to be Retailers and Import Penetration, Evidence from U.S. Dollar Stores. And my main focus of research is international trade, and basically thinking about who actually gains in terms of consumption from international trade. So basically thinking about consumption and trade policy and how we're going to think about the gains from trade policy or the costs of trade policy to consumers. A question that we want to know is how do imported goods actually move from the border to domestic consumers, right? We can track goods fairly well when they're moving on ships and when they arrive at a port, and we record goods in customs data as they move across international boundaries. What we don't really know is actually where do goods move once they hit those boundaries? How do they move to consumers? Do they move evenly to all consumers? Or is there some strong sort of variance across consumers in terms of their access to these imported goods? That leads to the second question, who actually buys imported goods and in what quantities? You might be surprised to know that in economics, we basically have no answer to this question as of right now. So why do we care? What is the precise statement that we want to answer with these questions? Basically, you can think of any change in trade policy from a consumer standpoint as a selective sales tax. If I put a tariff on Chinese goods, as of course happened in the US a few years ago, and we'll come back to this point, basically what I'm saying is if you buy Chinese goods, I'm going to raise your prices, but I'm going to tax those goods selectively. So if we know who buys imports and from which countries and in what quantities, then we can start to think about what the actual costs are of something like a tariff on Chinese goods because we know who actually buys those goods. And therefore, we can try to map into this selective sales tax type logic. Another way to think about this is who pays a tax on cigarettes? It's those who buy cigarettes. We want to phrase that, but in a trade setting. So who pays for tariffs on Chinese goods? Those who buy Chinese goods. And as of yet, we don't really know who those people are. So the two sort of standard assumptions in the economics literature right now would be one, if you live further away from ports, then you have less access to imported goods. Basically, if you live in Anaheim in California, you're closer to a port that's closer to China. Therefore, you probably buy more Chinese goods than if you live in Fargo, North Dakota. The other sort of hypothesis that's been put forward is that wealthier households just buy more imported goods than low-income households because imported goods are luxuries or what have you. Now, basically, neither of these assumptions has yielded anything interesting in terms of thinking about, again, how do households differ in their propensity to buy imported goods. Basically, this model of Anaheim versus Fargo, when it's been taken to the data, it's basically failed. There seems to be no difference between these households in their propensity to buy imported goods. And wealthy and poor households, when that's been explored, there's also very little difference between those households. So basically, we might live in a world in which there actually is no difference across households in their import expenditure, and therefore tariffs are affecting everyone equally. Or perhaps more likely, we've been looking in the wrong place. So the starting point of this project is exactly that sort of observation, that these two sort of approaches and assumptions might have been the wrong place to look. And I think sort of economists are often guilty of this. But again, data drives us to where we look. And as of right now, there's been a huge shortage of data that will allow us to take a deeper, more nuanced perspective on who actually buys these imported goods. So the angle that I took in my thesis and in this paper is thinking about how retail markets might matter for shaping the goods that households buy, and by extension, their propensity to buy imported goods. It's sort of weird that in economics, there's actually very little work thinking about retail markets and whether they affect households. If you've ever spoken with economists, you've probably heard some statement to the effect of, well, if markets are perfect, retailers just reflect your local preferences. This is the kind of statement that will make you deeply unpopular as an economist, because it obviously flies in the face of what most of us have experienced. If you've ever been to a Gulf island, you know that retailers dictate your choice set that's available. And in this case, it's especially true given that sociologists, nutritionists, etc., have done a really good job of documenting the fact that in low-income neighborhoods, retail markets do seem to constrain households in their ability to buy nutritious goods. It's also weird that retail markets and trade, sort of thinking about retailers and trade, this connection hasn't really been made in literature, partly because we know that large retailers play a huge role in international trade. Walmart alone is responsible for about 1,000 shipping containers reaching the US every single day. In the early 2000s, actually, about 25% of all exports from China to the United States was just Walmart. And so the idea that when we combine what sociologists have found with food deserts, with this fact that we know that retailers are active in international trade, it seems like a logical place to look of, do local retail markets shape your access to buying imported goods and therefore shape the outcomes of tariff policy, such as the trade war between the US and China in the last couple of years. And so basically, why have we not done this? It's a lack of data. So actually, there was this handbook chapter written by these two economists, Raff and Schmidt. Nicholas Schmidt is actually an economist at SFU. And their main point was just that we really don't know on the shelves of retailers and stores in basically any country what is the import intensity of goods on those shelves. Again, sort of a lack of data that some people find surprising, but as economists and even as policymakers, there is basically no evidence as to how stores differ in their import activity. You can look at customs data, but most retailers don't sort of actively ship the goods themselves. It's through intermediaries. So you can't just use customs data to tease this out either. So in this project, I wanted to take a look at that a bit more deeply. Think about retail markets and sort of import penetration to households. And basically, we need two things to actually sort of explore this. The first is we need data linking households to A, their local geography, where they live, so what is their local retail market, and B, their import expenditure. I need to know at the household level the country that they buy goods from and in what quantities. Second, we need some sort of natural experiment with retail markets, right? I need some change in retail markets over time that allow me to run a sort of social science natural experiment. Of course, it's not a hard experiment, but some kind of natural experiment to tease out the role that these retail markets play. And so basically the contribution of this project is, first of all, I'm going to have household level scanner data, and I'm going to make use of the recent expansion of dollar stores across the US to try to get at this hypothesis directly. So the research question will be, what happens to household level import expenditure after a dollar store opens in their zip code? I'm going to give you more detail on both of these points, the data and the natural experiment, in the coming slides. So for data, the key contributions that I use highly detailed US scanner data. Now, what does this look like? Basically, I have barcode level purchase records for over 50,000 US households over the 6 years of 2012 to 2017. So that's prices, quantities, store visited for each shopping trip, and each barcode that they purchased, the price and quantity, as well as detailed household demographics. I know where they live, I know their income, household composition, etc. Now, these data sets have been used in economics for a number of different settings. They've always had a limited use for trade because barcodes don't tell you where they're from. So I can say that you buy certain barcodes. I can't relate that to a statement about your import expenditure. This is one of the contributions of my thesis, was I was able to recover the country of origin for over 600,000 grocery barcodes using text on the packaging and a machine learning sort of technique to recover that text from images. How can I do this? All goods in the US are required to have some statement to the effect of made in China or product of Mexico on their packaging. And this allowed me to use the images of these goods or the packages and recover the text of where they're from. So basically I have 50,000 US households, all the grocery goods they buy, and all the information I can need about those households. And I've mapped that to the origin country of the goods that they're purchasing. The key element here is that I can track the country-specific import expenditure of the same household over time. So I can run this experiment within the same household. Basically, I know what you were spending on imported goods before a dollar store opened, and I know what you were spending afterwards. And that's the kind of variation we're going to use to try to get at this question. Now, in terms of dollar stores, I think the expansion of US dollar stores in the last decade in the United States is one of the more underappreciated economic phenomena of our time. Basically, 3 dollar store chains in the last decade have opened, on average, 3.4 stores every day over a decade in the United States. Those 3 chains are Dollar General, Family Dollar, and Dollar Tree. A fun sort of stat on that, there are now more Dollar Generals in the US than Starbucks, Walmarts, and Targets combined, which if you know how many Starbucks there are everywhere, that's quite a shocking fact. And in fact, the number of those 3 chains went from about 11,000 stores in 2009 to over 18,000 now, and that's in just 1 decade. It's sort of a useful natural experiment because I can show that dollar stores are actually quite import intensive in the goods that they sell. Basically, I can use my scanner data to show you that households are 3 times more likely to buy a Chinese good when they shop at a dollar store compared to when they shop at all other stores. So the research question then becomes, do you buy more Chinese goods when a dollar store opens in your zip code? And can we think about how that relates to the variation in import expenditure across households in the United States? So headline results, I find that for every new dollar store entering a household zip code, their expenditure on Chinese imports increases by about 24%, or about a quarter. The expansion of just these 3 dollar store chains alone can account for a third of the aggregate growth in expenditure on Chinese imports in the US over the last decade. Again, you think about all of the things that we think about as trade economists, exchange rates, technology changes, shipping changes. The fact that just the expansion of 3 retail chains can account for so much flow of traded goods as, I think, a deeply underappreciated aspect of what drives trade and how consumers actually interact with foreign producers. And then lastly, dollar store expansion. One of the reasons probably most of you didn't know that dollar stores have expanded so much is that this is heavily biased towards rural and low-income zip codes in the United States. So sort of putting this all together, right? We want to know, if we know who buys imported goods, we know who pays for changes in trade policy. So over the decade 2009-2019, dollar stores expanded rapidly in rural and low-income zip codes. And then in 2018-2019, President Trump begins his US-China trade war and increases tariffs on Chinese goods by about 25 percentage points. So basically, you can put these 2 together to show that US-China trade war and the tariffs placed on Chinese goods had an outsized impact on expenditure by low-income and rural US households. And you wouldn't know that unless you understood the changes in retail markets that had led up to that point over the last decade. So the implication is that tariffs, Trump's tariffs had greater costs for poor and rural Americans via dollar stores. Some sort of concluding thoughts, right? So research in international trade often relies on highly aggregated data, right? We like customs data. We like thinking about investment between countries and flows of goods between countries. But the data landscape is changing rapidly, and basically there's just questions that we cannot answer with this aggregated data. With new data, we can look for patterns that have sort of previously been unmeasurable, and this project forms part of a larger research project to understand how imported goods move from foreign producers to domestic consumers, and how consumers really interface with this world of globalization and international trade. And as a parting observation, there's sort of a butterfly effect logic to all this that I find sort of quite interesting. The idea that changes in local retail markets in rural America might somehow affect wages in Shenzhen in China through these links between foreign producers in China, their relationships with retailers in the US like dollar stores, the economic sort of phenomena that leads to these dollar stores expanding to rural America, and how that then drives production of goods from China to consumers in the United States. I find this sort of an underexplored aspect of international trade, and then linking that into what were the outcomes of actual observed trade policy, and that remains sort of the next step of where I'd like to go with this project. So that's it for me for now. I hope I'm still under time, but if you don't get a chance to chat, that's my email, so we can also, you can just send me an email if you're interested. So thank you so much.
Thank you. We are going to switch the gears, and we are going to go from economics to biology. And I felt this is going to be more like a little bit like higher education on the biology, but feel free to ask me any question wherever it's not clear, because I can understand sometimes biology is tricky. Nobody's interested in biology. But very simple title I gave to my talk was the Enzyme Revolution. So I joined UBC like last year, and before that I worked in States, and that's where I started learning more about the enzyme and how I can bring enzyme revolution in context to the whole like climate crisis and all. So the title is how we can use the revolution to reduce, to recreate, and to recycle. So before even going that, I would definitely like to do the land acknowledgement, which he has already done. Is that I would like to acknowledge that we are gathered today on the traditional, ancestral, and unceded territory of the Coast Salish people, including the territories of the Musqueam and Squamish and other nations which we don't even know that they exist here. So I really acknowledge that one. So coming to who I am. So I come from India, and I was born somewhere here in these Himalayan territories. And then I moved here. So I have been to be very frank, I have been to 11 different cities and 3 different continents and 3 different countries, 2 continents. And then I identify myself women in science. I do believe in that people do have to push them more for the science. And as a scientist, I define myself as a synthetic biologist, which you will know what does it mean. I have both academic and industrial experience, and that's why I want to build in that as a more applied science rather than just doing a basic science. And my lab is very much interested in identifying the sustainable solutions for the climate crisis. So if you feel that you could lend me some support at finding those solutions, so feel free to contact me. So my lab nowadays is known as the Biocycle Lab, and then where we do the evolution editing and engineering, which is very big terms in terms of like biology, but hope I'll clarify for you. So that's what we do. We do reduce, recreate, and recycle in our lab. So if you remember 2021, 2022, a lot of people remember it as the Corona time. But also if you think about the Vancouver people, you also remember this as there was a lot of fire, forest fire. There was flood. And then after the Ukraine war, we also saw that the people were crying for food and the food prices were going up. So, and then if you see the newspapers and all, then you will see that it was filled up with there is a climate crisis and it's ongoing phenomena right now. So my question to everyone is, do you really want to leave your kids with this? So that's answer will be no. And the thing is, I'm not the first one who is telling you that there is climate crisis, but unfortunately, I'm not the last one also. So that means people are talking about this again and again. So when you see the world, you will realize that we have a lot of people coming in, and then we have a big population to feed in. By 2050, we will have around 10 billion people to feed in. But at the same time, we are also thinking about how to improve the food production. We want to reduce the waste by 30%, and by 2050, the target date to reach the net zero one. So the idea is that everybody wants to, in plant world, wants to improve the photosynthesis so that plant can capture more carbon. You want to improve the yield so that you can feed more people. Then there is a lot of waste going in, so you want to find sustainable solutions. So in short, everybody is talking right now about how to do carbon farming. So, but before even going to carbon farming, think about the carbon budgets. I'm not sure what's happening. Okay, yeah. So if you think about the carbon in the atmosphere and there is like 100 carbon, a plant takes 100 carbon and fixes with the photosynthesis. What it does, it uses out of 100 carbon, 50 for himself. It does respire, it uses for its own purpose. Then 25% is given to us as a harvestable yield. Any grain or any such kind of food production is there. 25% goes as an unharvestable yield. That means a waste, which is like a food waste, feed waste, and all those things. Even if you divide more, carbon, a lot of 25% of the carbon it uses for its maintenance purpose. So plants also do their maintenance. So that's how you can define. Then plants are capturing 100, but they are not giving you 100% out. So what are these maintenance process? A major one is the protein turnover. So what people thought that if we can make photosynthesis better, we will increase the pie size. That means if you want to feed more people, just order a bigger pizza. So that's what people thought about it. This is one way of thinking about it. What I thought, why not just cut the pizza in the small size? Maybe people will feel. So I tried to change the reduced maintenance process, which is in plant, if you have enzymes which are using a lot of energy to do this, why not cut it half and then give everybody smaller pizza? Maybe it's full. And then you can feed more people. And if you have a bigger goals to do, or maybe bigger size going on, you can do both. You can order more pizza or bigger pizzas and then also make smaller slices. So coming to that, what I can do, if I can make extra carbon available, what we can do, and the simple thing is you can do a lot from it. You can make new biopolymers, you can make new bioplastic, you can make a new kind of product which you can use in your household. So that means that carbon is available, you can do a lot. In US, a group of scientists right now, what they are trying to do, they are trying to capture carbon and put it in the ground so that it will remain on the ground for a long time, and that's how you can reduce the carbon crisis. In short, you have to do a lot of redesigning, and that's what we do. To do a food, feed, or fuel-related problems, as a biologist, we try to do some revolution. And from my part, I'm contributing towards the enzyme revolution. That means I am a designer microbiologist who designs enzymes or make them better. Okay? So this is the Economist figure which came, and it talks about the synthetic biology, and that's how I define myself, as a synthetic biology. So synthetic biology is nothing where the engineering people and the biologists came together and they were like, okay, we will work together to find some solutions which can range which can be used in the modern day life. So that's how the biologists and engineers came together and they started working together, which is the synthetic biology. So you might be thinking, what are the example of redesigning the life? It includes that the new kind of threads or dyes you are getting in the market right now, they are actually designed from biology and where biologists coming together with engineers. So they are biodegradable. So they are not polluting your water. Then if you remember your Impossible Burger or these, I think it was Impossible Burger. That was also surely done by the synthetic biology. Even now, they have a yeast which can produce all the cannabinoids without growing the plants. So you don't need the land to grow these plants, and you can produce just in your bacteria or yeast. You can even produce scent in those bacteria, and you don't have to put a whole plant to just produce the scent or perfume. Even in case of Brazil, they are trying to run their buses by using biofuel, which is that the sugar cane, what they produce from there, they are making the gas, and that's how you can even run your gas by that. But I'll be honest here, it's not easy. So they are trying for a long time, and it's not easy. So that means somewhere we are missing that we don't have enzymes which are efficient. So enzymes are nothing. They are catalysts, which does a lot of reaction, but they are not that good. So that's what we do in case of reduce. We reduce the carbon loss. That means whatever carbon we are capturing, we are trying to use it for some useful purpose. So that means can we reduce that one? So how we do enzyme evolution. So you have all heard about the evolution for a long time now. And there is a new term added to it, which is a directed evolution. So to be very frank, it's just evolution in the lab. So we try to evolve things in the lab. So in 2018, there was a Nobel Prize awarded to Francis Arnold. It was for enzyme engineering by doing directed evolution. So just to put it in a picture, this is like this. You have one thing, you mutate it, and then you find, out of those mutations, one is doing great. You select that, you mutate it. So it's like finding something which is best out of mutation and all. So in cancer, cells are mutating and it's killing you. So that's not a good mutation for us. But there are some things which are where the mutation is for better. So that's what we are doing in the lab. But we are doing everything quickly. It's not taking years and years to do that. So we are doing in days, which took like for very long even for plants or even microbes to do it. So it's simple like that. You have a enzyme which is sitting there. You can make it B, that means a little bit better, or you can do a lot better. So right now, a lot of synthetic biologists are like just on B position. They are making them better, but not that good. So second one is recreate cell factories. So once you have these good enzymes, what you can do, you can just combine like this, that you can build whole set of them and put it in organisms, and that's how you can go. Either you can do like this, which our lab had done it, which is known as the Thi4, which is a thymine vitamin B enzyme, which has now is in a better form. The second one, people have done it to just change one thing, one amino acid or one protein sequence, and they were able to get it a whole evolution done like very quickly. So coming to that, you can put it in micro and say like, I want to produce B out of A. Can you do it for me? And it will do it for you. So that's what we are trying to do it in our lab. The third one is more realistic and which you will correlate. So think about your kitchen now. We are going from a dollar store to kitchen store. You get a lot of things and there is a lot of waste going on there. So what I personally believe that waste is not a waste until we waste it. So that's why people are keep buying and food and everything, and we are creating a waste. For me, I just do a metabolic engineering for valorization. That means I take the waste and I want to produce something useful out of it. And that's and that's how you enter in circular economy. You take it, use it, whatever waste it, again produce it, and you go in it. And that's what our lab does. It is taking something which you throw in the sink, we put it in the shelves so that you can buy it again, or whatever you are putting is the trash, later on you will use it as your treasure. So that's what my lab right now focusing on. So just come here and then see that you have agriculture and waste, and you have food waste. So if you throw it, it will go to landfill. That means you are using your land, and also you are using people to throw it there. What we try to do it, we use our enzymes to break it, and then you can make bunch of other things, which can be a sugar, phenolic acid or not. It's not enough. You can do bunch of things from here. You can produce vanillin. You can produce a lot of like acetic acid out of it. You can produce fumaric acid out. You can use vitamin C like citric acid, ascorbic acid out of it. So that's what we are focusing, how this food waste can be used to produce something very useful, which will reduce the landfill, also the manpower from it. Okay? So coming to that, this is one example. The AgroPower, you have seen this is the milk cooperative. They came to us in my previous lab and they were like, you know what, we produce a lot of cheese there, and then the water we throw, but the water is full of lactose. What could we do from it? Because for them, it's a tons and tons of waste. And for them, they can't even put it in the water stream because it has organic acids and lactose and all. So what we did, we used a yeast. Yeast is like what you put it in your baking. We used one of the yeast. We used their waste, and then we produce fumaric acid, which they are trying to put it in as a food additive. So that means, and technically, fumaric acid was always produced with a petroleum-based industry. So when Ukraine war happened, the petrol was so expensive. So they decided that this will be a better one. So this is just one example that when you make cheese at home, the waste you are creating, we are trying to use it to make something very useful which goes in the market. So other example is this, that in my lab, we are growing forest in a petri dish in a lab condition. What does that mean? You don't need forest and forest to produce cellulose. Actually, what we are doing, we are trying to produce bacterial cellulose, which is very high quality for your medical purpose, for your dye industry, for anywhere you use cellulose. That's what we are doing. The good part about this, we are using waste to produce this one. So the moment you have a forest waste, we use the forest waste and produce bacterial cellulose out of it. So that means that's how we are entering in the circular bioeconomy. So we are using a bacterial strains for it, and we are doing engineering for it. So my vision is that in my lab, we will be using a very small scale, but further we are partnering with some industries which will scale up these production. So maybe I'm using a little bit of bacterial cellulose in my lab, but an industry can help me to put it in a bigger and bigger fermenters, which will produce more and more bacterial waste out of it. So coming to that, the last, I would say for me, the foundation is very much equity, diversity, and inclusion, because we are partnering with the different industries as well as the indigenous people for their waste-related problems, so that we can include each and every one from the sector who can help us to get these solution for the climate crisis. And coming to that, like I said that in 2050, we have to do carbon farming, and our lab motto is we have to do some civil bioengineering from now. And that's how I started my lab, this lab for this. And at the end, I would just say that this was the team which helped me to start this process, and I'm hoping that UBC will be very much helpful in helping me that with the more collaboration, more suggestions from the community. With that, I would say that's what you want to leave for your kids. You don't want to leave those news or even the waste on the ground. You want to leave some beautiful environment and plants for it. So with that, I would say that synthetic biology just started. It's just a 10-year-old field, but it's just a revolution, and how people are using it, just the solution, what we can use it. With that, I would say that our lab is just started from the Darwin evolution idea, and we thought, why not? We can do it in our lab, and that's what people also believe right now. So in our lab, we are looking for some green solution, and I think Green College was that's how like it just I looked at the applications and I'm like, oh, that's where I'm going to find some green solution. So I'm very much looking forward to it. So So thank you very much, and feel free to ask questions. Thank you.
So, second stage, who would like to start?
Sure. I actually, in a past life, I had my undergrad here at UBC in biological engineering. So I actually have some, and if I was going to continue, it was with some of this thought of things like organic biodegradable solar panels and things like that I think are super interesting. Unfortunately, economics stole me away. But in terms of the questions of sort of, one of the things that always came up in these bioengineering classes that I found fascinating was this idea of separation, in that you can make these proteins within, E. coli or some other organism, but ultimately now you just have a soup of proteins with the one that you want, hidden somewhere in there, and you have to sort of separate it out in this multi-step process. I just find that to be an absolutely fascinating component of this, and thinking about where you can sort of, not to bring the economics into it, but bring down the costs and make these things feasible. Is that still considered to be a large part of what sort of is difficult in making these processes go forward?
A very good question. I think when I started my biology education, I think that was the time when just the sequencing, which from COVID, all of us know that how they were sequencing the whole, like our strains, bacteria strain, virus strains. So it was so expensive. I still remember it used to be $200 for one sequence. And now it has come down to not even 20 cents. So it's super cheap, and people have now put it a lot of money. And I think that I feel, that's why I remember during COVID time, my parents used to ask me, what do you do with this? Like how fast people are getting results, like this many people. And that's what I realized, that robotics, economics, and people have done so much analysis on these things that now they are making, I would say it's a very much automated process. So that's why things have become, the cost have come down. And that also gives you the boost that, earlier people were trying to do this enzyme engineering for 10 years, and now people are doing in 1 to 2 years. So that's how the sequencing cost, which was very much a heart of these whole biology processes, like DNA sequences, RNA sequences, and then after protein sequences, the cost has come down so much, and it was like amazing that how people have responded to it. And I think that's the reason that I would say that that's not now a bottleneck. I think the bottleneck, I personally feel, the people knowing what we could even do with these things. I think the knowledge behind this whole, the microbiology, or the whole, like what biology could do is amazing. And I think evolution, what people thought it will take years and years, and now scientists are doing like within days those evolution in the lab. So I think that's the major part.
Yeah, no, I think it's interesting when I talk with my students, economic students as well, about this, is that anytime you read an economic analysis that says X is not feasible, sort of my engineering brain kicks in, and presentations by people like you, it's like, well, okay, at what price? It is amazing what engineers can do, and scientists, and where we're headed with a lot of this bioscience and engineering. And I think that sometimes economists need to maybe trust that process a bit more, that nothing is static. And certainly not in the world of biotechnology, which is amazing.
Yeah, no, that's kind of, I personally felt like COVID got a lot of limelight on the biology side of it. What people, now I don't have to explain somebody what is PCR or what is the antigen test or what is the antibodies and all, because COVID did have a great impact on everybody's life. But what it did good for us was that people were aware that, there is a sequencing. I remember explaining somebody what is PCR, but now I don't have to explain it. So how far we have come with the biology is what I feel. And then, of course, the machine learning and the robotics and all came together, especially in the synthetic biology. The engineering came together to take it forward. So I personally believe we can't work in silos right now. It's more like all the science should come together to get the solution out of it. Because if biology keeps on doing what they do, it will take ages. But then the moment the robotics and engineering and machine learning comes in picture, it gives an answer like in few months or even within a year. So I think that's the major part, yeah. I have a question for you. It might be a naive question. Why US dollar store? Why not Canadian dollar store? I think you did the study in Toronto. So that means why?
There's sort of two questions. One is why are dollar stores doing so much better in the US than in Canada? And the second would be why did I choose that to study? The second question is easier to answer, although it's not as satisfying. The data is just much better in the United States. So the scanner data that I was talking about is available in Canada. And I have sent many emails that I imagine just got lost in the ether, but they've not yet been responded to by the company that does that in Canada. So it may be possible, but also part of the reason it's available in the US is because I would imagine, seriously wealthy donor at the University of Chicago actually made this available, and then UBC pays into it through a subscription basis. So it's not cheap. But unfortunately, that data is just not available in Canada, but we're sort of doing our best to get there. The more important question of why are dollar stores exploding in the United States is a question that I genuinely feel I cannot answer. I don't totally understand. Why would a dollar store become popular, right? It might be that everyone has suddenly become much more price sensitive, and therefore they need these lower price goods and they value them much more. That's one possibility. If you believe that story, then it sort of must be true that rural America is doing much worse economically than what our official statistics would tell us. Basically, the amount that dollar stores have exploded there seems out of line with what you would predict given observed incomes in these areas. So that could be one interpretation, is it's something of a canary in a coal mine, and that actually households there are doing much worse. The more positive explanation would be that there was some technological improvement by these dollar store chains that has allowed them to reach these consumers at lower cost. And the stories of these dollar store chains and their logistics are borderline apocryphal. But basically, if Walmart has bananas that are about to go bad, Dollar General will pick them up and ship them to their own stores and sell them at cents on the dollar because their consumers don't care about the bananas looking perfect. Now, how you make that work and still make a profit is something that I don't understand, and I don't think any economist does yet. And so we're still trying to figure that out. As of right now, we're kind of in the stage of, I think, being caught off guard by this rise in dollar stores, and we're definitely behind the eight ball and trying to figure out some outcomes associated with this. But what made it happen in the first place? Basically, I have no idea, and I don't know anyone who does.